The description that addition of water to calcium oxide causes the formation of a colorless precipitate and release of heat, in only words, is quite long. A short description is calcium oxide plus water gives calcium hydroxide. This is a word equation. The substances which undergo the chemical change are called the reactants and are written on the left side of an arrow in the word equation. The substances which are formed after the chemical change are called the products and are written on the right side of the arrow in the word equation. Plus sign is used to add reactants and products in the word reaction. However, the shortest form of describing a chemical reaction with least number of words and symbols is called the chemical equation. A chemical equation precisely describes a chemical reaction in a compact form by using the chemical formulae of the reactants and products. The reactants and products are chemical compounds. The molecules of these compounds are made up of the atoms of individual elements. A chemical formula describes the chemical compounds in terms of the symbols of the constituent elements and subscripts to represent the number of atoms of each element in the compound. The formulae of calcium oxide, water, and the compound formed after reaction, calcium hydroxide, are shown. Replacing the words in the word equation with chemical formulae of the reactants and products, we have the chemical equation of the reaction of quicklime with water. Example: zinc metal reacts with dilute HCl to yield zinc chloride and liberates hydrogen gas. Example: sodium sulfate of reacts with barium chloride to give white precipitate barium sulfate. Chemical balancing. In a chemical reaction, an atom is the smallest particle of an element according for its mass. According to the principle of law of conservation of mass, mass can neither be created nor destroyed. That is, the mass of the reactants and the mass of the products before and after the chemical reaction should not change. It further means that the number of atoms of each element forming the reactants and the products should remain constant. In this way, application of the law of conservation of mass principle on chemical equations gives rise to the need for balancing chemical equations. Now let us learn how to balance a chemical equation. Systematic method of balancing a chemical equation. Click each tab to learn more. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. An atom, a molecule, or an ion in the chemical equation forming one unit on its own is the formula unit. Step 3. Place suitable coefficients before the formula units for comparing and balancing the number of atoms of each element on both sides. Make a note. The formula of reactants and product cannot be changed during the balancing of a chemical equation. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Make a note. The coefficients should be reduced to their smallest whole number by dividing the equation throughout with the common divisor, if the need arises. Now let us apply these steps to balance an unbalanced chemical equation. Example 1 of balancing a chemical equation. Click each tab to learn the steps in detail. Propane C3H8 is a colorless gas with no smell. It is used as cooking fuel. It combines with oxygen to form carbon dioxide, water, heat and light. The balancing of the chemical equation of this reaction involves the following steps. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. Here carbon C, hydrogen H and oxygen O are the formula units. Step 3. For placing suitable coefficients before the formula units of the unbalanced equation. Place 3 as coefficient before CO2 on the right hand side to balance the carbon atoms on both sides. By placing 4 as coefficient before H2O on the right hand side, the hydrogen atoms in the equation can be balanced. To balance the leftover oxygen formula unit, we count the total number of oxygen atoms on the right hand side and find it as 10. The balancing of oxygen atoms is completed by adding 5 as coefficient before the O2 on the left hand side. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Let us learn to balance another chemical equation. Example 2 of balancing a chemical equation. Click each tab to learn the steps in detail. Iron oxide or rust reacts with aluminium to form iron and aluminium trioxide. The balancing of the chemical equation of this reaction involves the following steps. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. Here, the formula of the elements iron, oxygen and aluminium Fe, O, Al respectively. Step 3. For placing suitable coefficients before the formula units of the unbalanced equation. Oxygen atoms are already found to be balanced on both sides. by placing 2 as coefficient before Fe on the right-hand side. The iron atoms in the equation can be balanced. To balance the leftover aluminium formula unit, place 2 before Al on the left-hand side. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Now, let us learn about the factors that make a chemical reaction more informative.